800 trees, and I collected around 12,000 tree bags and processed in the lab. So my master and PhD is kind of mixed effect modeling, and my postdoc is new topic, and we talked with Dr. Sandy, and he said, "Hey Nova, I have a new project, maybe good for you." So I ended upon into this project, forest vegetation simulator. And as Dr. Bullock mentioned, it's getting popular over South because of this carbon project. Otherwise, like in South, we already have this big co-op and already refined good models than FBS. But anyway, now we have to learn about FBS, and I will talk about how we develop and what are the challenges and how can we use it for projects in company for carbon project. So what is FBS? FBS is like individual tree distance independent forest scan projection model. So it's projection models. It means like we will provide certain current scan input variables, then we will project into future scans. So FBS was originally developed in 1970s as a projection model, and from 1970s to 2025 now, it has more than 20 different geographical variants calibrated for each local regions. And also, it has other extensions like you can do some wildlife planning, some disease planning, and other modeling also. And for Southern Park, FBS variant was released in 2001. So why do we have to learn FBS? We already have this much like growth and yield system. I think you guys learned PMRC 1996 in Dr. Stephen King class and other PMRC model, and there is FMRC and other like co-op. Why should we learn FBS? First, it's publicly available and it's transparent. You can find everything about FBS online. You can find its code in GitHub. So it's publicly available. Another, it is I think only, there are others also, it is the most accepted by leading carbon forest register like ACR and BERA. So they you have to use FBS for carbon calculation for carbon project. And also there was like it's 2024 report, I think, among other available model, FBS is the highest ranked model in terms of usability, model complexity, and analytical capacity. So it is quite popular now in southern part. It is popular in northern more. And also it's used by so many companies and consultants for forest planning. And this is one of the example. Like when I search for a job, there is like it's mandatory now you have at least experience using the forest vegetation simulator. So you have to have certain knowledge of FBS when you go for carbon project. So for this class, I try to make it brief so that we can go for training. So what are the important terminology we encounter when we search about FBS or when we want to learn FBS? So it is program using Fortran code and some code are supplemented by C++. Maybe we don't need that information, but we need other information below, like it has graphical user interface. Like if we go to PMRC site, we have like PMRC sign here. It's similar to like that, and it runs online. And another important concept is keyword file. Another is event monitor, key component file, growth modifier, and calibration. We will learn briefly about this terminology in the next slide. So if you have downloaded FBS, you must have seen this interface in your computer. And today we will use this graphical user interface for some simulation example. So it's also called FBS Online. If you go to FBS User Guide, if you see FBS Online, it's the same stuff like Forest Vegetation Simulator graphic user interface. Another is key file. When I talk with company people about FBS, they mention, can you please share your key file? At that time, I didn't know what is key file because I was using graphical user interface. So key file is like when you have 100 or 200 plots, you can easily use graphical user interface. But when you have, let's say, 2,000 plots, now you cannot do like some modification from like user interface. Or let's say some product are inventory in certain year and other are certain year, then you have to modify most of the stuff. Then you need .key file. It is like have you used RCPP package in Dr. Steven class, like loading C++ coding to R? It's similar to like that. It's like Fortran code, and you will provide certain scan information, and you can use RFBS package in R, and then you can uh, run the simulation. Another is like event monitor. The event monitor is like kind of helper function. Like when you do certain modeling in R or whichever software, you will write certain helper function to calculate like certain evaluation metrics, mean square error or certain stuff like that. With event monitor is like you can provide certain custom function inside FBS, and then you can have variable that you wanted. So this is event monitor, and it comes in like .kcp key component file. Like it's a key component file, and it looks like this. This is the example. These are the terminology when you go to FBS. If you want to learn more, then you will encounter. These are just examples. And another most famous one is calibration. We need to calibrate FBS. We need to calibrate FBS. You have heard a lot of that. If we don't calibrate, there is like certain publication they have been publishing, like the FBS is kind of over projecting tree per acre. It's killing less trees. And for northern part, it's over projecting basal area also. For southern part, what I have found is it's under predicting the basal area. Means trees are growing slower by a BS. But this result is kind of contradict. If you attend Somen's conference where Mickey presented, he said like basal area is also over projected. We are working on that and we are trying to verify that result too. So what you can do is like you cannot fit whole FBS, but you can have certain calibration modification so that you can bend FBS towards your observation through growth modifiers. Like you can provide, let's say if it's killing less tree, then you can provide certain modifier. I want to kill 15% more tree, then you can bring FPS towards your original observation. If you have any question, you can ask in the between, like let me know.
No, I have a question. If it's like really bad at certain parts in certain regions, why don't they just update the variants?
Like variance. Okay, so like
Because if it's under predicting mortality, why don't they just fix it to instead of the user having to fix it?
it's quite complicated. I think uh, people who develop, I already talked with this, the people who develop FES, these people are kind of retired or dead. And also, some people are dead, they presented it. And also, for calibration, we need data, right? And our plantation data is like all with co-op and they are maybe not willing to share it. And like for publicly available data, FIA data set, some are in plantation, but some are in like natural forest. And it is calibrated using like let's say 20 years back or like it's better if they calibrate now, but it's not working, so we have to work now. So how FBS work? This is the graph you will find in FBS like user guide, but I simplified it because we have limited time. So we will provide inventory data set into FBS, then it will calculate initial stance characteristic, and then when we specify treatment, then it do certain management intervention, and then it will grow larger tree. If it's like larger tree for whole FBS base, it's 5-inch diameter. If it's larger than 5-inch diameter, it will first grow DBS, and then from that DBS, it will predict height. If it's smaller than 5-inch tree, it will first grow height, and then from height it will vary deviate. And then based on that, for southern variant, it will use SDI index to calculate mortality. There is two mortality. One is like background, which is like logistic equation kind of like for probability of tree dying, and another is like after it's hits certain SDI, then tree start to die. And then it gives output. And if it's for one projection cycle, we already have output. If it's multiple projection cycle, then this output will be fed into input, and then it do cycle of projection. The main important thing when we use FBS is like FBS input, mostly scan information. Tree information, we already have three high DBS, count ratio, whatever, but main thing is like scan information. And FBS is kind of developed to use FIA dataset. I will say that. So FIA has mainly three plots. One is like macro plots, which we use for larger tree, and subplot for sapling, and smaller plots for seedling. So let's say they use like Prism to do like variable uh, inventory, but in South it's mostly like fixed plot. We use fixed plot size. If they use gain basal area factor, then they will provide positive value. If it's fixed, it's negative value in the same column of Excel. We will see it later. And then if it's a small tree plot, let's say macro plot, then we will provide if it's 1/3, then we will provide 300, and it's a big diameter, which is like how do you differentiate between small tree and large tree. These are the kind of information we need to provide. Here is one example. Let's say we have 10 basal area factor, 110 uh, for 5-inch sapling, and 1/3 for like seedling. Then how do we provide information is like FBS is designed to have only two plots. Now we have three plots. Then we need to convert it into per acre basis. We cannot input directly like basal area factor 0. Why? Because we are specifying inventory plot as 1. If we specify 1, it will get like 1 acre plot. And then we have to calculate number of tree from small plot to 1 acre. And for count for seedling also, we need to use uh, expansion factor to like make it or calculate it for per acre basis. For today's example, we are using CAPS dataset. It's like 1/8 fixed plot per acre, or it's 1/8 fixed plot. Now we need to convert into per acre basis. And what we will do is like basal area factor 0, inventory plot size 1, which is 1 acre plot. It's a break diameter. It's like it says like now we don't need to break diameter because we are providing per acre basis. And for tree count, we are using plot size into number of tree. Let's say if we have like one tree in a small plot, then that will represent in 1 acre 8 trees. We will use expansion factor like that in Excel file. If you have question on this is the most important one we will see in Excel also. What does FBS takes? We need to provide scan attributes and tree attributes. And FBS is designed in such a way if you don't provide information, it will take its default values. For example, you are doing a simulation for lower coastal plain. If you don't specify ecoregion, then it will go for Alabama and put default value. And if you don't specify slope, it will use 5% slope as a default. If you don't specify elevation, it will use 700 feet as a default. So we are talking about southern gradient. And like that, and the most important thing I already mentioned is like basal area factor, inventory plot size, and break diameter. These are the most, otherwise your result will come in like millions of Morrison table volume if you don't correctly do this stuff. And these others are like three variables. And like without input, only providing scan level variable, it is capable to simulate, or with only diameter also, it can simulate you the result. So if you can provide as much as information when you are using FBS. Like then where can we get region and ecoregion? We can get it from FBS software website. It's a zip file. Then you can upload your coordinate and then do like uh, intersect, and then you can find the region and ecoregion from there. And where we can find slope, elevation, and aspect, we need to use the digital elevation model available for US. And one easy way to is like, I think you already learned it in Dr. King in class, like Google Earth Engine. Use Google Earth Engine, upload your point, and calculate slope, elevation, and aspect, and extract from there. So far, so good. Any confusion? Let me know. Again, not just for things. Then where does it like where is this variable are used? It is used in like diameter increment model. If you can see, there is somewhere slope, elevation, habitat type, and stuff like that. So it is used in the main diameter increment equation. Another important thing is that in southern part, we do site index for bases quantified, but FPS considers site index uh, for bases 50. So from we need to calculate site index for bases 50. Otherwise, it will consider default value for white oak, which is 70 feet, which is way lower for our Loveland pine. So we need to calculate site index and provide it for FPS. One challenge with FBS is like FBS is designed to cap site index for a max of 125. If you get site index 130, then it will lower and make it 125. That's a challenge we need to work for future. We are trying to have some height modifier or diameter modifier to do that. So this is the main issue and about FBS, information about FBS. If you have any question, let me know. Otherwise, we will go for FBS training.
Now, will you go back to the graph with site index and caps? And just, I think it's important that people see the number of observations above the maximum line here, right? And look at some of the densities. They're not all, they're in operational densities too, 300 and 600 and 900. So, I mean, looking at that, you would just immediately say, wait, it's going to way underestimate stuff, right? If that's your max.
That's a red line is max.
Yeah, I know. That's what I'm saying. As a modeler, you would look at that and say, ugh, that's not good. Okay, good, thanks. Any other questions for Nawa so far? Okay.
All right. First, I want you to look where do you install your FBS? Maybe most probably on drive C, and you can find FBS here, right? And if you see here, there is only blank database. There is Excel, there is MS Microsoft Access, and SQLite. And this Excel sheet where we will generally input our inventory dataset. And for FBS scanning it, we will provide the scan level information, and there is FBS tree in it, where we will provide tree level information. For most of the inventory practice, we usually don't use plot level information, but if we have like 3 or 4 plot within one scan, then we will use plot in it.
So is there information somewhere on what values you should not put in like certain columns or like the units for height? I'm assuming they're just going to be feet.
Yeah. Like I didn't provide this because I don't want to make you overloaded. There is like thousand variant like this, thousand variant
Okay.
overview.
Yeah.
Also there is like FBS user guide which is 300 pages. So you can find information like that, and like in the first page it's like giving warning what are the default value it will use in those tables. So if thousand variant you can easily download it online. And another is there is FBS software. If you are planning to use, let's say, 2000 plots, then you will need this. Within FBS software, you have FBS bin. Within bin, there is .dll files, which are Fortran files, and you can load this into R or your terminal, and then you can provide those key files and then do simulation. For today, we are not going to do that. We are going to use graphical user interface. And your all run project will be like storing this FBS project, FBS folder, and you can later upload it. You can share it. You can see the result in it, like that. Okay, let's open FBS. Did you already download the Excel file?
So you want them to all open FBS right now as well?
Yeah.
Okay.
Could you open your Excel file? I have provided only two plot information because I didn't know how much data I could share with you all. So, but from these two like this example, you can upload as much as data you have and run the FBS. The main thing is like if you see here, if let's say we all familiar with culture and density tree, right? Are you familiar with it? Like we have two management and we have different densities and we have 17 installation. Then two management, 6 density, and 17 installation. Then we have this amount of plot combination. And if we are planning to use FBS for carbon accounting and stuff, then we have to make unique ID for each plot. This is for caps.
I just want to make sure, was the Excel in the email you sent, or?
I
Was
think
it
It's
the
in
one
Bronson's
I
email.
forwarded to everybody
Okay,
with the, had a Microsoft Word and an Excel document in it?
okay.
just let me know if I am going faster because Dr. Bullock said you have to finish on time, so I have to.
Did I say that?
And if you see here, I have latitude, longitude, region. I downloaded it from save file, or for southern part, it's region 8. And this is the location code from the Excel file in online. And this is equation that you will also get from FBS softwares online, and you have to intersect with your coordinate. And this is like inventory age. We have expecting delivery, slope, elevation is from here, but the thing I want to address is like this three thing. For lower one, I converted it into per acre basis. So I already said basal area factor is 0, inventory plot size is 1, which represent 1 acre, and bed diameter we don't need it, so it's 9991, and number of plot is 1. But for upper part, I am using -8, 8, 3, and 1. To give you example, if we have fixed plot, let's say we have 1 by 8, then we will use -8 to represent this is the fixed plot. Otherwise, it will consider it as a visual area factor. And inventory plot size is like when we have 1 by 300 plot, we use 300. So now we have 1 by 8, so I use 8 here. And break diameter for southern part is 3 inch, so I am using 3 inch. But for our plantation, I think we don't need it, but we have to provide it.
So why the second one has like why do you have like those base values again? Like
Just to show you different example.
um,
Either you can convert it into per acre basis, or you can directly use your measurement plot information here. And you can do it through R, like you can input data into this through R, and if you are interested, we can talk outside. But for this class, I think let's do that. And in next plot, we have the inventory information, and I think there is one mistake in your tree count. One we use expand like 1 acre, for another we use fixed plot, right? For first one we use fixed plot of 1 by 8. Another we convert it into per acre basis. So for first scan, it need to be tree count should be 1, because 1 tree represent 1 in 1 plot. But when we convert into per acre basis, then it's 1/8, then our 1 tree should represent 8 tree, because we converted it from 1/8 to 1 acre. So here you can see tree count is like 8. So for this first part, like just go there and make it 1. I think I check both and for to like, could you make 1?
So you're just showing us like two ways you can do it.
Yeah.
Okay. Okay.
2 example. Any confusion? Okay. So this is our FBS. It looks like this, and it has so many tabs. You can here simulate, use output, visualize, visual map, manage project. I will go step by step, and then so you can learn how, like what each tab does. So I don't invest more time on explaining this tab. So go to manage project, and we need to make new project for this, because your tab have project 1, which is default example project, I think. So make it FORS 8050 and click make new project, and then open selected project, and it will pop out new windows or new tab in your same. But I think I already have it. So video, does new tab appear? No?
do you see the tab guys?
Yes.
Okay.
Okay. Let's go to manage project again. And here is import input data. And browse to the location where you have saved your input file. And make sure it's open here and expect well. And you have to install your database, otherwise it will not appear there. Install uploaded database. And if there is any error, it will flash out here. Something is missing, some plot ID is matching, we are having some error, like it will pop out here down. So far it's working. Let's go to simulate. Then you should see something like this. Did you all get it? Okay. If you see here in group, because I have provided only two scan, let's say if you have like 200 combination, then it is coded in a way that you can select base as 10, 15, 13, whichever way you want. And you can select that as the age you want to project from. So for this, we have only age 10. So if you select age 10, two group will appear. This any will work as an OR function or function, and all will act as a like and function. Like let's say if I have age and block and then I have cleaning treatment, then if you select all, then it will select scan that have like not clean from that block and that like intersection block. You have to select both of these. You select here. If you go down, then select the scan, then it will appear here in like content view. And let's save this as run title as base one and save it, and it will save here and go to time. Now we have to specify time from which year to where we wanna like project. By default, it will give you a current time, but let's say we have a stamp from 1999 and we will project for 5 year interval. So 1999 plus 5 is 2004. And let's do for like 2034. And for southern gradient, when I showed you that diameter increment equation with slope and elevation, it is fitted for 5 year increment. For other variant in north, it is fitted for 10 year increment. If you do for let's say 7 year, 10 year increment using the southern variant, you will have bias region. You have to have like 5 year increment. If you do 7 year increment, it will either go outside from 10 and do linear interpolation and pull over 7, or more generally, if you make a longer projection than its default, it will have more bias than less projection. If you use 3, it will have lower bias, but if you use 7, it will have more bias. For this is like basic step. Just now we have said like from 2014 to 2024, we want those projection in 5 year interval. Let's go to select output, and we want to visualize. It has a function that it will visualize how your scan structure look like after current status to another status. It's not good, but it's good for certain presentation and stuff. For now, we will only select 3 lists, but we can have lots of variable. We can select carbon and other stuff, and then go to run. Let's give this management ID. We are doing this because later we are going to do thinning, so we don't mix max. Yes, do this base one or whatever name you wanna, and then save and run. Now you have merging table. It's the default way. It will give you like merging table volume from like if you have any error, it will have like some error is flashback. Now you say FBS error scan, no error found. Right? Are you following? Okay. I might go a little quicker because okay. Now we have output, right? View output, view output, go to base one. This is our output. First, we wanna look at scan level table. So let's calculate summary. Then it will show you how many variables it has calculated in your pen. You can either select only one or you can select all and then go to explore. For me, what I would do is from there, I would download CSV file and then do all the stuff and analysis in R. So I'm more familiar, but here we can visualize something. If you see here, both plot have same TPA, visual area, SDI, everything.
My first one has a TPA of like 5,000.
Did you change it to 1?
Mine goes 616 to 77.
My too.
You are getting different results or?
I
The
can
first
send it.
TPA is 616.
Uh-huh.
This second TPA is 77.
Can
It's still running. Video turned on.
Let me make it sure. I will do all for you. Just can you open your Excel file? We have got different results. Go to standing it or go to 3 count. Can you make it 0? It's 1 for like first one is stand. And 8 for next stand.
Mine is 1 the entire way through, it looks like.
No, it's not entire. First plot 1, second 8. That's why you got lower TPA.
Okay. So
Because I put different example for each stand, so we need to provide different 3 count. And I made error while sharing data with you because it's all in on there. And you can go and reinstall it. You don't have to do anything, just run it.
Okay.
And in this visualized tab, you can select base run, select image. We can provide inventory condition here. And when you are doing inventory, it will provide you dynamic plot. Your scan looks like this. And let's say after how many years? Let's say 14, 24. And how it looks like.
Do each of the trees have a spatial location in the?
No.
So it's just like
visualize it.
it just makes it up.
Yeah.
Okay.
You can see here, certain tree are already dead with scan. And these are failed tree. And you can see bigger tree. And what have it happened here. And when you thin, it will also show here. And if you don't want to see this, you can unselect down too. And it has another feature here. If you on map, you can view this in map also, in like Google Earth Engine. Not Google, Google Earth Engine. I think those plots are now failed. I don't know.
Yeah, they were clear cut.
Yeah,
Yeah.
but you can see here, and when you what variable you want to see, it will appear in table here. This is designed that you can upload your shape file of plot into it, and it will like cover area and show you like your shape file of tree and yeah. Okay, are you alright? Let's do another the spinning practice. We'll create new and do it like base 2, save it. Then we wanna let's do thinning only in one plot, but we wanna we need a reference. If we think what would be reference look like, then so here number of replicate of each stand you can see here, make it 2 and X selected stand. And you can see here R1, R2. And both time we need to provide again 2004, 2034. And here comes component, where you can provide management, what kind of management operation you want to try, modifier, if you want to kill more tree, if you want a more volume or whatever, and event monitor, if you want your costume output here, and other keyword, which is like you have to modify STI. Let's say keyword here, base system, and STI. So, what is the maximum STI for level defined?
In reality,
Yeah,
140?
I think it's 450, right?
450 is commonly used.
Yeah, but it used 480. It was the question appear in comments also, like STI, it used 480 and it used 85% for max. So let's put 450 here. This is the example of how would you modify your keyword. And I would assume, like, I'm not sure we are discussing it with Dr. Yang also, for max SDA or it can reach maximum density. If we use 45, then it should be 100%, 10-inch tree. Or I don't know what Dr. Bullock said on this, but for now, let's use this. Saving ground. Management, we want a thinning and pruning operation. We want to thin from below. And whenever you specify treatment, it should be in the beginning of cycle. Whichever cycle, let's say, next cycle is 2008, you cannot specify a thinning operation in 2007. If you want to specify 2007, you have to adjust your cycle length to appear it in the beginning of the cycle. So, at what age, in 1999, it was age 10, and 2004 it should be S15. Let's do thinning S15, and for 3 per acre, let's make it for like 350, thin up to 350, and we can do proportional thinning and everything here for make it basic, just saving run. But to save it in run, we want to do it in replicate 1, so let's save this one only. component below. Or if you're in both, you can delete in one just to make it like reference we can. Oh, it is one we have. Oh, you have to see it in the scan. I'm sorry. Oh, yeah. Did you able to do that? No? Let's see. Example, you can do it. Just you have to select on the scan ID here to insert any scan. And then select output. You can run here and run. It's merchant table volume. R2 is where we have like 10 options. And we can explore in output.
No, how come we didn't see the fin there? Not opposed. Oh, okay.
Could you say it again like you
The fin, like we didn't see it.
that's the merchant table volume stuff. I don't know. We can see it. Let's try on diameter.
Okay.
It should go like this. But if I don't like we will clean it to raise the density. This is where you can select TPA, came up to 350. And then visual area is reduced here. And then you can download this table and explore in R, or you can use Excel to that, and you can make like nice graph here. That's it. It is visual area by year. And if you want to have it in like this. And you can modify this plot as much as you want. Just you have to play it around. It's easy, it's like sign in, go and play around, compare with your original. Sometimes it's give you goofy values, so verify if your observation. Yeah. Any question for me? And there is like most advanced thing you can do is from like component. It's you can specify management, you can modify like volume, diameter, height, whatever you have. And if you are a programmer, you wanna do it programmatically, then you can use .key file. And there is key file. Let's say when I use SDI max, if you wanna like exert certain value and something like that, you can go to that key file and then modify certain value that you would like to have. And there is some concept like if you modify for diameter increment, height is predicted from diameter, so don't do diameter modification. There is certain rule. There is one paper from 19th, 9 feet. there is use and misuse of growth modifiers. If you are gonna use the FBS, you should go through that paper. Other than that, we have basic cleaning simulation. I don't know if it work with you or not, but we can do it. Keyword modification, we modify SPI, it's basic, you can do. And thank you all for being present, and thank you Dr. Bullock for inviting me here. Also, he's one of the PIs in this project, and Cassie and everyone. And there is second concept. I didn't know, like, we don't have more time. If you had asked some question, I have few period, but I didn't get any question.
Yeah, so I guess I would say I encourage you to play with it. Maybe not right now if you're not actively using FBS, but find time over the break or something, install, upload, look through some of the options. Different organizations are using FBS now as a part of their carbon projects in a very large way. And so having some basic knowledge of it, as Nawa said at the beginning, it's included as one bullet line when you're applying for a job. So having some familiarity with it would be a good thing.
So like